I want to talk about slope in this video, so let's start off with positive slope and what that looks like. Positive slope kind of looks like a positive correlation. So we know that a correlation, when it's positive, it looks like this. The points are going up. Okay, correct? Well, a positive slope on a line, so I'm going to call this a linear equation, and it is a linear equation because inside of the word linear is the word line, creates a line. So this is a positive slope from left to right because it points up. So while we're doing this video, if you could just take your left arm real quick and point it up. Your left arm should be pointing up now, and you'll see that that is a positive slope when reading it from left to right. Now if I put this positive slope on all four quadrants, it's going to look something like this. As you can see, when I read it from left to right, it's pointing up. This is a positive slope. Now let's talk about a negative slope. Well, you know what a negative correlation is, so you should know what a negative slope would look like. The correlation that's negative would be this. This is negative because it's pointing down. Now let's look at a negative slope in quadrant 1. It would look like that, kind of like the trend line we used to draw when we had some negative correlations. And so this is your negative slope line. It's like going down a hill, so down the hill, and the other one would be like going up a hill. This is going up the hill, and negative slope is going down the hill. This is what the negative slope would look like in all four, or rather when all four quadrants are drawn. Okay, so it's going down the hill again. So go ahead and use your left arm and point your arm down. It should look like that. Your left arm, no, you have to do your left arm. And so you see, going left to right, it's pointing down. That's down the hill. That's a negative correlation. Now let's talk about the two that we've been practicing with all year. The y value and the x value. We have learned that the y value is output, the y value is dependent, the y value is range, the y value can also be f of x. Well, the x value is domain, it's input, it is just x. Am I leaving anything out? Independent. We know all of those things are true. So what does the graph of a y value look like? Remember, it's a horizontal line. And how do I know that? Because when we were trying to find the range and we folded that sticky note gave us a horizontal line when we traced it. So this was the sticky note we used, and when we folded it, we drew that line. It was horizontal. So remember, horizontal lines, they give you y values. But now I want to know, what is the slope of this line? Well, Mrs. Major had talked to us about a guy that's walking. Would this be fun to just walk on this here? Probably not. So we're going to call this 0 fun. And why is it 0 fun to just walk this plain old straight flat line? Because the slope of this line is 0. So when I ask you what is the slope of the line, remember, it is 0. There are two ways I can write that. I can say, well, actually, there's more than two ways. I could use the word slope and say it equals 0. I could use the letter m, because m stands for slope, and say it's 0. I could say that the rise over run is 0. I could even say that y2 minus y1 over x2 minus x1 is 0. This is the slope formula. This is the slope formula, but written in word form. This is the letter M from y equals box x plus box. This is the M spot, the slope spot, the pattern. And the word slope just describes it. We also could say that the change in y, there we go. The change in y over the change in x equals 0, because this is another way to say slope. You can also say delta y over delta x is 0, because this is slope. So don't be confused. This circle here, 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 they all mean slope. So the slope is 0 for this 0 fun line to walk. Now let's talk about an x value. The x value, it does that. So this is the y-axis, the x-axis. This is an x value. So what kind of fun would it be for a guy that would walk this? Probably no fun at all, because what would happen? He'd die. He'd fall right down, and he would be what we call dead or undefined. So the value of the slope for a vertical horizontal line is undefined. That is why when I asked you a long time ago, is this a function, when you had dots here, you told me no, and I asked you why. But when you draw a vertical line through it, it hits it 1, 2, 3, 4, 5 so many times you can't count it. And I know that because the arrows keep going. It's not a function either. Well, that has something to do with the fact that it's undefined. It has no slope. That's why when you write the equation for it, it's just x equals some number. Now that we've gone over that, let's review. We have going up the hill as positive slope. We have going down the hill, negative slope. We have 0 fun. So the slope of this line is 0. And then we have undefined, dead people because they fell and hit the ground. So that is slope in a nutshell. To help you remember those 4 things, we're going to use the slope guy. The slope guy says, let's draw the nose, and that's a vertical line. That's the bridge of the nose. And then under here is the nose, so it's undefined. And then you have a vertical line, it's undefined. Then the mouth is horizontal. And then the chin tells you that whenever you have a horizontal line, it's 0. Okay? Now we do the eyebrows. And this one is pointing down, so he's negative. And then this one is pointing up, so he's positive. And this is the slope guy. So you can use the slope guy, draw the slope guy, whenever, to help you remember pointing down, down the hill, negative slope, up the hill, positive slope. Vertical line, guy's falling, it's undefined. Horizontal line, mouth is closed, it is the 0 fun that the guy would have if he were to walk that simple straight line.